Hi everyone, thanks for coming today. I'm Roman and I'm here to make some of you uncomfortable for the next 25 minutes or so. Long story short, last November I gave a talk at PyCon Wrocław with rethinking how we build Python applications. You can find the text version here. There's a QR for scanning. The best part of any conference, as you might know, is usually not the talk itself, it's what happens between the talks, during the coffee breaks, all the informal life, behind the scenes is where actually the conference is. And my talk was a fast-paced tour of real-world cases with some practical insights. And surprisingly, the one that triggered people the most was not about DDD or hexagonal architecture or whatever. It was about ORM overuse and my personal journey from ORMs are fine for most cases to please no ORMs never again, okay? And I believe that I had about a dozen of really deep conversations with talented engineers where, they were, skeptical to my pitch. And they were right. Because, of course, you must be cautious about all the radical claims from people you barely know, right? And developers have very mixed opinion on that, I know. And they use quite different approaches to achieve the same goals while building real products. So do you, I bet. So do I. A few words about myself. So before I start, a bit of context, just 1 minute of self-presentation, if I may. I've spent about 20 years in IT in general, including 15 years building software for money, working on some of Ukraine's largest marketplaces, and more recently at the leading UK fintech company you all know about in London. Today I'm founder at Haifa, where we build tools, systems, and products we wish existed, as I frame it, to solve some real-world problems. So far, we have shipped 2 great products I'm genuinely proud of. First one is Haifa TV. It's a video-on-demand platform for professional creators where you can sell content directly to the audience with instant settlements worldwide, unlocking global creator economy, and there is no middleman. Works like magic. And Jailrun, it's so-called radically simple and coherent way to run your stack, powered by FreeBSD. It was born as a side project to run our own bare metal infra, because you might imagine how expensive it is to run 4K video streaming these days in clouds. And it's open source, and you can learn more about that scanning the QR. You're very welcome. And speaking of Haifa TV, it's a pretty big and complex project with dozens of services, with integrations, hundreds of schemas, and so on. Well, you can imagine how big it might be. So from the backend perspective, it's what I call the great boring stack, because it's boring and it's great. So we use Python, FastAPI, Postgres, Redis, nothing super crazy, and some pretty cool bespoke solutions on top of that and between them, so everything works smoothly all together. And Postgres is our main database for a very good reason you all know about. Postgres is an amazing piece of technology. It's powerful, it's efficient, it's stable, it's predictable under heavy load with good isolation guarantees. It's a true state of the art. And for some special use cases, like real-time dashboards, sort of, we also use TimescaleDB, which is essentially just an extension for Postgres, designed for time series data. It gives you a lot of cool stuff like automatic partitioning by time, compression, and what we use the most are so-called continuous aggregates, which are technically materialized views that refresh themselves incrementally when needed. So we don't have to build and maintain this Delta-like architecture on your own. And being a relational database, the language we talk to Postgres is, of course, SQL, because SQL is a great DSL for relational data. SQL is expressive, it's declarative, it's extendable, it has like linters, it has formatters, it has visual schema tools, and beyond. A huge ecosystem has been built around it for years, you agree? So SQL is gold. SQL as a language has an ISO standard, but practically, of course, we all use one of many dialects that differ a bit in details, like DB-specific features in Postgres or those in timescale DB, DuckDB, ClickHouse, whatever you use. And speaking of Postgres, my favorite example is always for updates keep locked mechanism in tandem with native Postgres listen notify pops up. Using both, you can easily implement a simple and robust event-driven app with concurrent consumers able to scale horizontally while tracking processing and with strong consistency at the same time without losing a single record. Simple as that. And here is the trigger function. I hope you can see at least something. Every time a new row is inserted with a pending state into the tasks table, it builds a small, tiny one JSON payload and calls native PG notify function. That's it. That's all you need, basically. Postgres broadcasts the event to connected listeners. And for update, how it actually works. For update locks the selected row for the duration of the transaction completely. Skip locked means if that row is already locked by another worker, just don't wait, skip it, it's fine. So multiple consumers can poll tasks simultaneously, concurrently. Each one grabs the different tasks with no conflicts, which is, well, what we need. And here is the consumer side. On start, it acquires a dedicated connection, right? Subscribes to the tasks channel. We have a dedicated channel for that. And when a notification arrives, the one our trigger sent, it parses the JSON payload, it extracts the task ID, and spawns an async task to process it. Now be very careful here reading this one. So this task acquires a connection and calls the repository method, the one with the for update skip locked I've just presented. And if the task is already taken by another worker, we get nothing back. It just skips it safely with no conflict, no errors. And if we do get the task, we look up the right consumer for it. No consumers registered, we mark it as orphan, just skip it as a debuggable state that we visually can debug later. So otherwise, we update this state to processing and spawn the actual work, as you can see here. So notice that the connection remains open the entire time. So the row remains locked until we're done here, right? Very explicit. All in code you can read from top to bottom. You can follow every single line, what's actually going on here. And chances are you don't really need Celery or whatever you use for similar needs for your project. Maybe at your scale is just too much. Which means fewer moving parts, less infra to maintain, less things to debug. Cool. And Postgres, of course, has many more features worth your attention, like window functions, like recursive complex CTEs, efficient partial JSON-B indexes and querying, and like other partial indexes. Well, just know your tool and use it. That's my point. And SQL allows you to access all these rich features in a readable, declarative way. So how cool is that? SQL is gold. So why do ORMs exist then? What's the point? There must be a problem they might trying to solve, right, if they exist. And surprisingly, many developers don't really understand what ORM is. A bit confusing with query builders, maybe. So let's clarify it first. What ORM is? ORM is literally an object relational mapper, as we all know, right? It maps database table to classes and rows to objects. It lets you use some language-specific DSL instead of data-specific DSL, hiding the query complexity behind its own abstractions complexity native to your app language. You got the idea? So to make everything feel like more object-oriented, as if it's something good. So, but in Python, actually everything is an object. If you fetch a row with async PG, it returns a record object. A Python object representing Postgres row, right? Is that an ORM? Nope, because ORM goes further. ORM manages bidirectional mapping between relational data and model objects. It tracks object identity. It synchronizes state changes implicitly for you. It maintains a lot of internal caching and a lot of more stuff. If you ever explore the code base of SQL Alchemy, you might know for sure it's full of ancient dark magic to make everything work together. But for most of us, it's okay, right? We're just okay with that. You might even think, well, if it's so complex, the problem might be complex. And it's great that we don't have to implement our own ORM every single time, right? And for sure, we don't want to do that because we're not crazy. No. And those who are not okay with that, they usually go a level down to query builders to have more control over the resulting SQL, staying like closer to actual database concepts and primitives like explicit joins and clauses. And SQL Alchemy Core actually exists for a very good reason. And it's what most of you, I guess, actually use instead of ORM. Because experienced engineers, they all know that ORM is never a good choice. And you will have to fight the tool right after the requirements are not trivial anymore. Unless you enjoy Django for some reason. And then you don't actually have a choice. Now let's ask the right question. And the question is, what do we actually want to achieve? Why and then how? So obviously we need some translation layer, right? Some glue between our aggregates and the database to fill relevant domain models with actual data from the database, to run some processing after in the business layer, and then persist it back to the database once it's done for later. And the code requirements here are the same as anywhere else. So we want something readable, maintainable, composable, testable, reasonable, type safe, and so on, right? And since database interaction is I/O, always, and your domain layer should not contain any I/O, never, by definition. Your actual work here is somewhere at the edges of your app, so you must push all this work to the edges at least, because you must keep I/O at the edges. And that's where you create so-called repositories, right? A repository is an injectable dependency. It means it's scoped, it's very limited, and it has some boundaries to work within. Your main work with the database is here, and once it's done until you change your schemas maybe, or decide to add some new filters to your collection methods, whatever. After you complete the modeling in the right way, you have the business logic, you have the interfaces, and so on. Actual interaction with the database is the very last thing on your to-do list, actually. Maybe the very last one. At least it should be so. And if it's not, it's actually not your fault. It's probably your favorite framework is pushing you away from God. So after you're done with everything else, time to replace stubs, time to implement the protocol with real DB pool connections, with real queries. And well, if you did everything right, you have the aggregate models already for everything. And after some actual work, they are of course populated with some data that we need to persist somehow. And for that, we need a driver to connect to the database. And well, we all know that SQL is the language of the universe. And all you need basically is to prepare a correct query and a set of arguments right from your aggregate, just in place. And if you feel bad looking at this slide, that's okay. But there is nothing wrong with having SQL strings in your Python code, and that's why. First of all, it doesn't break separation of concerns, if you're thinking about that. Because separation of concerns is about technology boundaries. It isn't about technology boundaries, it's about responsibility boundaries. And here, the code, the snippet, the SQL snippet, and the Python code, they do the same thing together. So they are responsible for the same thing. And the second one, it follows the so-called locality of behavior principle I'm trying to promote, meaning keeping all the code for one behavior in one place to reduce the context switching. Like, look, everything is here, right? And it's safe because, of course, we use the driver native query escaping for arguments, and it's completely readable. And since we write tests for it anyway, you will definitely catch silly typos like hanging comma. Same for query methods. You prepare a select statement as pure and efficient as can be. You just must have an efficient resulting SQL, right? Including CTEs for complex queries like in-place array concatenations if needed. You're not limited to ORM or Query Builder anymore. You can just use the whole power of SQL here. And you populate aggregates with raw results. That's what you do. And for complex parameterized methods like this one, there are some rules of common sense and a few, let's call them best practices to keep everything clean and testable. Like you prepare grouped conditions and arguments together, they go in pair, and you keep the body of the SQL query itself, the core body static, and you compose everything together when it's time and run it, and it's done. So is it error prone? Of course, if you're not careful enough. Same way we could say that Python is error prone because it allows mutable arguments and functions, or because it fails on circular dependencies, whatever. And just don't do silly things and use TDD. Even though I'm personally not a big fan of TDD, it rarely actually works well. Repositories are one of those cases where writing tests first actually makes a lot of sense. Write tests first. After you have a few of these, you might notice that these two methods have something in common, right? You might want to reuse parts of the query. And ORMs shine here a lot because of the method chaining, letting you extract common parts as a basis for other queries for later, something reusable. And even though this is possible here as well, you can easily extract the whole part to some function or submethod, whatever, and encourage it. Blindly following the dry principle can easily lead you to violate another more important rule, more subtle one. Locality behavior is always more important than dry, always. So what I want to say here, by splitting the query chain into parts, you end up spreading the query composition across your repository, in the best case, or across several modules, in worst case, undermining the main advantage of locality of behavior. You don't keep behavior scoped and contained anymore if you do that. So if you start noticing repetitive parts of your SQL across several methods, and you feel this natural urge to refactor them into something reusable, just not to repeat yourself, stop right there and just don't. Because the optimization might look concise on the screen, it might look nice and neat, but it won't be in your head eventually, even tomorrow, and ultimately making it harder to follow and maintain. And it's perfectly fine to have repetitions across your queries. It, of course, may take a bit longer to review them when you change schemas or like the shape of the aggregate itself, maybe. In practice, this process is very infrequent, surprisingly, and pretty straightforward. In return, each method you declare this way, each method of your repository, it remains isolated, it remains atomic, it's readable. There is nothing from the outside to break it somehow implicitly. And you can always review it visually without extra hopping, without need to rebuild the full mental map in your head of how these things combine into a query somehow. And that's what truly matters. All right, but what if we change the schema or even the shape of an aggregate? Can it break? Can it break our repository? Of course it can, and it will. And because of the exception propagation, the whole execution path will fail, of course, when you, for example, fetching a collection and one of the items is malformed somehow. Whether you want to fail or not, it depends on the requirements of the calling service and on business requirements, of course. And sometimes you might want to suppress it to keep the whole thing running. Sometimes it's better to honestly follow loud. It depends. In some cases, missing a few records is much better than just a blank page with 500 error, right? Because of the malformed data. So you can wrap everything everywhere in try except blocks, of course, but that suppresses everything in place, and you immediately lose the error, the error context. You might want it to explicitly handle it somewhere else. And what we actually do for Hypha-TV is all repository methods return so-called either container. You might be familiar with that or not. If not, it's fine. You wrap an actual aggregate or an error. Either a container can be left or right, where left contains an error and right contains the safe result. And they both have a handy set of simple methods, same sets, like unwrap, get or none, or get erase. That's it. Unwrap returns whatever it has, treating an exception as a value, which is useful for logging, for example, or some corner cases. And on this slide, it doesn't actually matter what you see right now. You can see the complete implementation of this container. It's an actual code. That's it. Super simple, and it works really well. And also, I like it the most because it colors objects from unsafe methods, if you know what I mean. They allowing you to distinguish them in services everywhere, and they force you to make an explicit and visible decision, like, do we want to fail or not? And if yes, how exactly? So having that all together, what we have for now, we implement the repository the right way, we run efficient queries, we keep everything scoped and readable, we keep our domain models dumb and clean, we call the repository method safely because of the other container, we use static typing everywhere, of course, we have absolutely predictable results of what the actual query will be, and that solution is that simple. So nothing crazy, and sorry if disappointed. So ORMs, that's my main claim here. They don't give any real advantage at all. And ORM provokes wrong design. ORM is an anti-pattern, literally. So if you see that your framework is forcing you to rely on ORM, change your framework. You have Postgres, you have SQL, you have driver with just 10 methods that do exactly what they say, and that's it. You have no magic, you have no hidden state, you have no hidden tricky caching, whatever, no lazy loaded relations that fires like thousands of queries to a database because someone has added new field to serializer. And that's it. Thank you so much. You can follow Hive on Mastodon, follow me on LinkedIn, and read our blog. Thank you very much. Let's stay connected.